Okay, so this was the problem that I created that was supposed to be your problem. And you recall when you had it, it was simplified. And let's go through. Oh, it's supposed to be there we go. Friday the 13th is the workbook I wanted to get to. Okay, so the problem we had was we were given 900,000 accounts, and we were supposed to steal money from them. So, I mean, I know it's very important that you came to college to learn how to embrace your criminal side. There actually is logical philosophy to that in many engineering aspects. If you're trying to engineer something that has regulatory constraints, if you know how to cheat, you also know how to do it right. So what we're showing you here is how to steal money in case this engineering gig doesn't work out for you. At least you can make a living, especially with the executive order signed today that the government's supposed to study digital currency and ways to use it to steal even more money from taxpayers. So this may be unintentionally a very important lesson so that we can continue to eat. So in the actual problem, there were 900,000 accounts, and you're working at a bank, and you're supposed to calculate interest for those accounts and then credit the interest back into the account. That's how interest-bearing accounts work. When I was your age, interest-bearing accounts were, in college, were about 16% interest. That actually is pretty good. I mean, that's a doubling time of a little over 8 years. So that was a good thing, but there were no jobs back then. Bennigan's hadn't been invented yet. Uber was just a wild dream. Amazon didn't even exist. So times have changed, but interest-bearing accounts haven't. It's just the amount has changed. So what happens? You have a certain amount in the account, you calculate the interest, and you take that interest and you pay it back into the account. You reindex the value. So if you start with $100 and you get 1% per day, let's go ahead and do a ridiculous amount. So compounded at the beginning of the next day, how much interest have you earned on that $100? 1% of 100 is $1. And then that dollar is supposed to go into the account. And now the account has $101. And then you do that again the next day. And now you've earned $1 and a penny. Goes back into the account and so on. So computationally, if you were doing that with floating point arithmetic, you would, from time to time in those calculations, get numbers that have a lot of decimal points. And the banking industry realized years ago, well, we'll just go ahead and truncate everything, round it, because people don't work in mills in thousands of a dollar, and we'll just kind of keep that. If you have 900,000 accounts, even if you're making 1/1000th of a dollar every day, that starts to add up. But us working for the bank realized, our supervisor doesn't really care. They just want the customers to have. Why not just put that in my account? So that's our task. We're going to go ahead and simulate doing that. Now we're going to have to finance this illegal operation. So we're going to go to the mafia and borrow some money from them. So it's in our best interest to know about how much money we're going to make so that we can negotiate a decent loan from the mafia. We won't get a good interest rate from them, but
I don't think the mafia negotiates.
But we're going to negotiate a decent loan from the mafia. And we have to be sure that we have enough to pay ourselves, pay them what we agree to pay them, and to pay them again what they decide they've just changed their mind.
Yeah.
Because if we are loan from the mafia, what happens?
It's a standard 30% per person.
Yeah, it's so the first time we fail, they're just going to break our legs. Fingers?
Yeah, the pinky, they jaw off.
No, they break your fingers first because you need your legs to walk the bank.
Fair enough. Yeah, we're doing US mafia. We're not doing Yakuza because then you would start losing fingers. First one, just to prove that you're not going to rat us out. The other one as punishment. And then if we're really bad at missing payments, it just toppers us and game over. Okay, so there's our setup. Let's go ahead and simulate how we might do that. The actual exam problem was we had 900,000 accounts and they were identical. So to do that in the actual exam, there were a couple of ways you could take it. Well, one way, which is actually probably the fastest, is to just figure out the behavior for a single account, multiply the result by 900,000, and that's the end result. But let's go ahead and do the problem the way it was. Well, we'll just do the problem the way I would do it, as if the accounts were different. So we have 900,000 accounts. We'll go ahead and create them. You see the two commented lines, because then we'll go back and do the problem the way it was originally intended by God and the place on the internet from where I stole it. We'll go ahead and create the 900,000 accounts. So all we're going to do is the NumPy array. We're going to create an array that contains 101.23 900,000 times. Hit the doodle and it's done. And then let's just go look at what the contents of the first account are. 101.23. Let's look at maybe the first 10 accounts. How do we slice an array? What do I, 0 to 9 or 0 to 10?
0 to 10.
So the first 10 accounts, lo and behold, so they're clearly identical. Our next task was, we could have programmed the whole compounding of stuff ourselves, but decided that truncating at the thousands is actually a little harder to do than it is to describe. So we just provided a function that does it for you. Now, this is a function not unlike anything that you've all taken off the internet, because you've gone to the internet, you've got code, you embed it into your code, cited it and used it. That's fine, that's the intent. So this is a function that takes two inputs, current value and daily rate, produces two outputs, whole dollar amount in the skim. And so let's go ahead and prototype the function. And we don't even need to look at the details of the function. We're allowed to assume that it works correctly. But we should probably test how the function works. So I'm going to create an object called current value by simply just taking a value from one of the accounts, account 0 in this case. Are you just really tired, or am I that boring? And I'll take the daily rate as the float of 5 or 365 over 100, although it was given in the problem statement. And then I'm going to use the add interest function. I'll supply it with the current value and daily rate. I'll take the output of that and I'll put it in an object called trash. And then I'll go ahead and print trash and see what's there. Questions on that? None? Good. Okay, excellent. We proceed. And so in our example case, we make a whopping 1 penny of interest in 1 day, which I guess isn't that bad. And the see, what is trash? And the other part of the tuple is the amount of money that we skim. We're able to take out of any single account 0.000386712 dollars. Not very much. But you multiply that by 900,000 and that starts to add up to real money. So that's how the function works. Now let's go ahead and just write it into a script that does it for 1 day. Okay, so I've actually completed the script, so I just changed the input and then I will describe it. So the way you would do the simulation is, first we would have to make our simulation work for a single day. So at the beginning of the day, how much money do we have in our Bitcoin bucket? Nothing. How many days have elapsed? None. We do know a daily rate that happens to be a constant, so we compute that constant. And now we're going to go ahead and this particular highlighted for loop, what does that working its way through. How many times is that loop going to execute?
900,000.
900,000 times. So we're working through each account. And then for each account, we get its current value. We get the update tuple, and then we're going to go ahead and apply to the account the amount to add into it, and then apply to our Bitcoin account the amount to add into it. And we'll do that 900,000 times. And then we'll go ahead and print some output. So I've added a little bit of extra feature to this based as compared to this morning's video, which I'll go ahead and I'll link that too. I have the time, the ability to keep track of how long it takes to do stuff. So what I'm going to do is I'm going to time how long it takes to go through a single account. It claims it's going to take about 13 seconds based on what's laying down here. And I've set it, see, all days less than 1. I think that will run, that'll execute 1 time. So I'm just going to do 1 day. It should take 12 seconds. I'm not about to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 9, 9, 10, 11, 12. Ooh, 4.8. That makes no damn sense to me. That was on the same computer. No, I know that. It was taking 12 seconds per day.
So this did all 900,000 accounts?
In
for
4
1 day?
seconds, for 1 day in 4 seconds. And in the process, we stole $3,480. That's not bad for a day, not bad for a day's work.
All in a day's work.
Yeah. Now let's go and just run it for, see, what was it? The problem was 100 days. I'm just going to do 10. Although the fact that it's now going to take 40 seconds instead of 400 is kind
No,
of,
it took 4.8.
oh, something's broken.
Oh, it's doing them one by one.
As I told it to.
Huh.
There we go. So at the end of 3 days, we got 10 grand. That's almost enough to have a good party, right?
It's 14 grand by then. 4 days.
So we're even gonna have an open bar. Come to our thieving party, open bar.
Oh, look, it's already at 20,000. That's at least like a
You know, I
4K.
don't trust open bars anymore. There was an open bar in the football, like, you know, the VIP suite,
Yeah.
and it was just beer, like,
Oh, that's not an
Not
open
even
bar.
good
That's
with
just
beer.
beer.
that's sad.
And
And again, it's
it should stop at 10 days. So in 10 days, $34,000.
the mid-range SUV right now.
Okay, now let's do the problem the way it was supposed to be done. So if every account's identical, you didn't have to do it that way. The way the accounts were supposed to be set up is they were supposed to be uniform, random distributed between $100 and $100,000, just like a real bank would be. So now I've just rebuilt the accounts. So the first account has $7,300 in it. The second account has 26,000, third account 55,000. We got one account that's got 90,000. I could do any of your accounts, but I can't represent integers that small. Sorry. So that was like a 25-minute lead into to a punch. So now we have randomly selected accounts. Let's suppose we wanted to visualize that. What would be a good tool to visualize what the accounts look like? I agree. I think it should be a histogram. Now, I don't think histogram is built into NumPy, so we're going to have to go find code to do histograms. But hopefully I have it laying around in my answers. Oh, that's panda histograms. Scheiße. Well, I really want to get the histogram. I've got 11 minutes. We can do that. So what lecture had the histograms in it?
Literally all. Like since 12, every single one had some sort of.
Since 12, everyone had a histogram. So I have a It looks like a histogram to me. We're actually going to do it the hard way, though. Oh, that's a bar chart. That's useless. There's my histograms. Did I always do it in a data frame? Ah, crikeys. Well, I'm not going to bother with it. I don't have enough time. Pretty good cop out. Let's see what lab 15 had.
A year left.
A year? A year of what?
Life.
You're in a good mood today, aren't you? Okay, well, we'll just have to wing it. So if I produced a histogram on those 900,000 accounts, it would look like would be a little wiggly, but it would just be from 100 to 100,000. It'd be kind of a uniform distribution. So there's no preference for any particular part. The mean value of a uniform distribution between 100,000 and 100 is dun, dun. It'd be 50,000 plus 50, so it'd be 50,050. That's okay. That's why you're going to be an engineer. We have something that can be quick with math on our behalf. It's called Friday the 13th.ipynb. So there's our random accounts. Everything else is unchanged. We're obviously going to make more money per account. So for example, whatever the first one is, we made a whole $1 of interest. Not much in the skim, that particular account. But now let's go ahead and start stealing from a real bank. And it's taken a little bit more than 4 seconds now. Why is that? I don't know either.
Are you stacking the accounts or are you
It's taken more than 4 seconds now because every time it has to re-access the function. The first time it passed through and realized 2 identical function calls were identical outputs, and our silly kernel is trained to notice that and say, well, I'm not going to do any actual arithmetic. I'll assume the human just doesn't know what's going on and do it the fast way. So now after 3 days, we have 13,000. So there's a little bit more money in this range than there was with $121 per account. And it just goes on and on and on. I'm going to now terminate it. And okay, let's see why I have the timer. So right now it's taking 12 some odd seconds to do a day. A logical way to actually script this, assuming you believe everything is wonderful about Python, would be to actually, so this would be a fairly Pythonic way of doing the problem. So we're now just putting the function call in directly. Okay, very subtle and minor change. Let's see how much faster or slower it runs if we do that. Because we're not doing this in a data frame, we're not using the symbolic apply to do an entire column. And actually, I have no idea what's about to happen. It didn't give me the pink screen of death, so at least something's going on inside. Those squirrels are squirreling away. Squirrel, squirrel, squirrel. So it's about 1 second faster to do those intermediate computations. So that is very anti-computer science and anti-engineering, but sometimes when your stuff is running slowly, the simplest practical fix is to do intermediate steps and just store stuff in temporary variables and draw from the temporary variables. And there's no way you would know that going in, unless when you started out your computing career, you did everything in assembly language because that's the only tool there was. And you get good at doing this. So that was an example of simulation. So let's see what we did in simulation. We went ahead and created the game, the problem, the gambling tool that we wanted to do. We did it for one time, verified that it seemed to work correctly for one time, and then we hit it with the repetitive steps. So in banking, actually, this is how banking codes have to work as a matter of regulatory reasons. They actually have to do per account at a time. So that explains why when you go ahead and run your credit card, the bank immediately lets you know, yeah, we know you just spent money, but we can't reconcile this till tomorrow because you're one of 14.7 million customers. And we have to run this through our servers every night. We have to have a human being babysit the program. We have to have another human being supervise the results and authorize them, and then we update your account. So the reason banking takes what seems like a long time is because there is actual time involved in the computation. And then there's also the other time involved. It's like, well, if we sit on these people's money for 3 days and then credit it to them, we got 3 days of interest on 14 million accounts. That's some serious cash. We'll be able to have an open bar without beer, but with real beverages. Okay, that's all I want to do today. I am fully aware that our Friday class is at 4 o'clock, a day before spring break is supposed to start. I am not authorized to say, don't bother to come. I have to be here, but I'm fully aware of the fact
There's going to be 2.5 people.
the fact that the room might be empty.
Yeah.
Don't worry about it. Use the lab today to get everything that's due done. Yes, sir. I have a feeling my computer's not going to work right on Friday.
This is perfect. I'll get you done by daytime.
I was just teasing you about the yawning, so don't.
No, you're good. So when I put my classes in focus, I kind of like submit that stuff. And then whenever I finally submitted last, I did.
Yeah.